person. Yay! Do we have anybody in my lecture room? No, everyone's gone home. So there's been one new commit in some of the repos. Okay, so it's 10 past. Wondering how many people we actually have hanging around. At least there's 2 people who've said hello. 3. So we do have some people, yay people, who are here listening to me. Okay, so I'll see if I can decrease the background noise. Is it too background noisy for you guys, or how is the audio for you guys? There seems to be a wee bit of background hum, but hopefully it's not too bad. Okay, so today we have a couple of options for the lectures. I've actually got a couple of one, the ethics, which no one had voted for, but we're going to do because in the course we have to do the ethics. And there's only a couple of other votes, a couple of discussions on code reviews and coding styles. Now, the couple of lectures I was discussing, looking at doing, one was, a relatively straightforward, simple discussion on design patterns as a programmer, programming design patterns, and the other was on professional ethics. I quite enjoy the professional ethics lecture, though admittedly it is best when there's a group of people to have a good discussion with. And I see there are 2 listening in, and at least 4 people have waved on the channel and might be listening on YouTube. So they can see the potential for what we're going to talk about. So the question becomes, what do people want to do in terms of the lecture today? So is it ethics or design? I can also, talk about other things if there's a particular topic that you're wanting me to talk to. Though if you do that, I probably won't have a themed NTNU logoed version of it. But we could talk about other things. Oh, actually, I suppose if I'm going to make a poll, I need to separate those out, don't I? So I should really not give you ethics or design. I should go. I've not done enough polls, so I need to really create better polls. So there is a way of doing polls, I just haven't done them on Discord for a while. So I can't hear anything. Is that just me? Thomas, you've got your microphone muted, but you should be able to hear me. Can other people hear me? Oh, good. Okay. Hi, Elizabeth. Oh, my audio is a bit on the low side. Shall I? I'll try and. No, I think maybe that. I'll try and get. I'll try and get a wee bit closer to the microphone. I'm extremely low on YouTube. That's terrifying. I should try. What I'll do is, I think that's decreasing gain. the road seems to be at maximum gain. So if I do, that's just those speakers. Maybe if can I change that to increase the gain on the microphone so that you can hear me a wee bit better? I don't know if that's actually having an effect on that. I'm just trying different things to see if I can get this microphone to give you a bit more audio. The last thing I can try is open my sound settings and try and increase the microphone settings. Device property. Right, I can whack that up to there. Test. Okay. That's the maximum I can set it to. That appears to be getting more into the red for the road on YouTube, so hopefully that's got a bit more pickup and a bit louder. Right, hopefully that's a bit better on the YouTube side, and I'm more into the yellow so you can actually hear me properly. I do have a proper microphone, so hopefully that'll do its job and give me reasonable audio for the session. Right, so as I was saying, if we go for ethics, are there enough? I see that there are 5 of you there, because if I do ethics, oh, excellent! I'm glad I've fixed the YouTube link. It's always good to have at least some audio without having to blast your ears off to turn it full volume. So if we do ethics or design patterns, so the ethics lecture, I actually have. I'm asking you guys to give me feedback, because we have a bunch of topics to cover and interesting discussions to have. Now, ideally, we'd probably actually have, everyone's going with design patterns. Okay, that requires less input and effort from you guys, so that's fine. I will do the ethics lecture at some stage, or it's running pretty even, the discussion with it got 5 and 3. So the ethics discussion, we'll dig into some deeper topics as well. I might flag for you guys that next week will be the ethics topic, and if we've got more votes at the moment just to talk about design patterns, we'll talk design patterns. Flag for you guys for next week to think about the ethics, and we'll have the ethics lecture. The ethics lecture I find quite enjoyable, so we can run that later. It'd also be really good if we could have someone who was keen to do some code review later today, or we can just go over some of the interesting weirdness of computer hardware with some code that I have around pointers, which we can discuss why you use it and those sort of things. Okay, so given I think we still have a clear winner on a 6-4 split vote, now remember we're doing team decision making. This was a voting decision making, so we've got a 5-4. It's so close. Okay, well, if you guys are fine with doing the design patterns, I'm happy to go. Has someone been unhappying themselves? Oh my, you're now 4 each. How can I make a decision? Well, you guys have just done that intentionally to make my life more difficult, haven't you? Okay, so what we'll do is we've got a couple of people typing, so there's going to be something being said. Sounds interesting with computer weirdness. Okay, we'll have a look at that code after we do a lecture. We'll quickly go over design patterns. Yeah, fair enough. Okay, so if I switch over to this one and we go here, right, real-time changing plan, great. Well, actually, yeah, real-time choosing. So if we go to present, does that? All right, I'll move that a little bit so that it goes there and goes like that, so that you can actually see it all, and it not got too much of me covering up the top corner. Okay, so design patterns. So what I mentioned these when we talked a few weeks ago about using standard ways of solving problems, and that standard ways of solving problems help other programmers know what you're doing, right? So this is one of the benefits of communicating in a professional manner is using understood means of doing things. So when we look at these reusable solutions, part of that, the purpose of that is to do that communication. So a design pattern, as I said, is not a finished pattern, but it can be transformed into code. So it's this idea that it's a design that you can transform into code. It's not an already plug and play solution. It's an approach to a solution. It is the description of a template that solves the problem. So if we have a look, there are a couple of large areas of design patterns. So we've got programming design patterns and usability design patterns. So the usability ones, which we covered more of in the design courses, are things around HCI, computer interaction design patterns. Things like graying out options in drop-down menus, right? That's an interface design pattern. Because, and I don't know if you've ever had this, but if you've got a menu and you have a menu from the top and you click on it, it drops down. If options change and disappear, then it feels like the order changes, because instead of that option being option number 3, it's now option number 2, because option number 2 has disappeared. That's really, really bad interface design. Is because the way people mentally operate, what they do is when they click on the menu, they click on the third option down, because they always know the third option down is the one they want. And if you reorder that, oh my god, they get incredibly pissed. Now that's a usability pattern because it's the way in which humans use the software. There's also design patterns within programming. So we're going to talk about the programming ones because I'm assuming you're all programmers. Well, you're not all programmers, but you're mostly programmers, and you can find the design patterns. So some of the design patterns for usability. So the design patterns we're looking at for programming, we're going to talk about commands, flyweights, singletons, strategies, factories, spatial indexes, and composites. So these are all different sets of design patterns for programming. So if you guys have questions, just pop them into the Discord and I'll answer them. It's actually interesting. At the moment at my university, we're currently discussing how we deal with COVID-19. I assume that the Norwegians might be also starting to worry about coronavirus. We're just about to start our semester, so we've got a whole bunch of Chinese students who are supposed to turn up, and now they can't be here, so we're going to have to do this style of teaching, and all the other lecturers are freaking out and not knowing how to do it. So hopefully, I can't infect you with COVID-19 if New Zealand ever gets a case. But yeah, so we're going to go over these particular these patterns. Okay, so the command pattern. Now, if you know all of this, just tell me and I can skip forward fast. Okay, so the idea of the command pattern is that often you'll want there to be some way of configuring something like a mapping, right, for keys, right? So you want the left key to move left and the right key to move right, and then you say, oh well, actually we want ASDW to be equivalent to the arrow keys. So this would be a remapping. And so a naive way of doing this is to have like one big massive switch statement and then try and change a mapping file and say, oh, equals this thing, and you look that up and you just have a big switch statement that goes through and looks up all of the potentials, right? That's a relatively ugly thing to do, because what happens is that every time you go into the switch, you're having to look through all of the potential cases, right? So when you're trying to find which what action a particular key does, having a switch statement to go through all the potential actions. Clutters your code and is slow. So the command pattern says, okay, let's turn a function like move left into a full proper object, right? So it's now, and it's a method call within an object. And so instead of having a pointer to, instead of having a lookup that says a switch, and then so with the switch call the function move left, what I do is I actually attach that object that has the function move left to the keystroke, so that when I press the key, it triggers that command. And if I reconfigure my keys, what I change is actually that direct mapping. Right? So I don't have a switch statement, I have a function pointer. Now, in OO languages, you will often have a polymorphic function that you can point to. So instead of calling the function, we call exec on an object. So what I can do is I can have an object that is the move left, it has something called execute, and if I want to trigger something, I just say, okay, this is going to trigger an object with an execute. I will call execute on whatever object you give me, and so when I look at that code, I can't actually see what that execute function is going to do in that part of the code, but it means that I can always replace the object to get different behaviors. And so this is quite useful if you're going to have different objects called like an idle object or an attack object. So you instead of having the behaviors being call attack or call idle, what they are is you point to the idle object and it has an execute function in it. And so I see, equals execute, and if I'm in the idle object, I do that thing, and if I'm in the attack object, I do whatever execute of that task is. So that's a kind of command pattern where you're using equivalent of function pointers. Have any of you done function pointers? I'll just check function pointers. Because we can also, that's not how you spell function pointers. We can also do some discussion on function pointers, if you like, because function pointers are they warp with your brain a little bit, but once you understand them, you start to understand how objects work. But function pointers is the idea that instead of pointing to an object, you can actually point to instead of pointing to like an integer, you know how you do that like the ampersand to generate a pointer? You can actually have that to functions, and you can have function pointers. And then when you want to call some code, you can pass it a different function by the pointer to a function rather than having to know the name of the function. And that can be quite useful when you want to swap out different pointers. So I have some code that does that. If you guys are really fascinated, we can talk about that and after the break. Okay, so that's the command pattern. It's this idea that what you're doing is you are, instead of using switches, you are actually doing callbacks on objects in OO languages or function pointers. The flyweight pattern, this is quite common. You'll find a flyweight pattern whenever you have a large number of objects that you want to either put on screen or have in a simulation. And the naive solution is you just buy more RAM, because once you've used up your 16 gig of RAM, you just buy another 16 and make your machine 32. But that's not always the best option. And so the idea is that we actually break what we normally think of as good OO style, right? So in the flyweight pattern, it says instead of putting all of the code next to all of the function code next to all the data, if you're going to do things like have 1,000 trees, and they're 1,000 pine trees, and they're all pine trees, so they all have the same leaves and they have the same bark texture, and so they have the same function calls on animating them, and they have the same rigging in the on the branches and stuff, and so it's kind of, they're all the same, why would I create lots of duplicates of a heavyweight object? That doesn't make sense. What I should instead do, have this idea of there's an object which holds all of the code and all of the textures and all of the types of leaves. That's an object. And then I create lots of what's called flyweights, which are merely the position of the tree and potentially like the height of the tree or the age of the tree, or a spawn value for the tree. So let's say I've got like 8 different pine trees, types of configuration for a pine tree. So I have position, size, and an int saying what type of pine tree it is. And those objects are now have no code associated with them. They're incredibly lightweight. They are just basically what we'd call in C a struct. They are an empty, they don't have any code, they are just the data. And then what you do is you have thousands of those very, very, very tiny objects and one heavyweight object with all of the actual information in it. And so this allows you to do that separation. And so if we look at it visually, the idea is instead of having every tree with all of its information, you have one tree with all the information and then lots of just positions of those others. Now you'll see this if you ever go to particle systems, you'll be able to see that particle systems will often have one thing that describes the complexity of a particle, but then every particle itself is merely a position in a lifetime. No more information than that. And that's really important. So slide area, you don't buy RAM, you right. Buy RAM. Right. So the idea here is it's breaking that original way you've been taught to use objects, because that way doesn't work for what you're trying to achieve. Now, you actually see this, and although I talk here about visually, you can have this problem when you're dealing with massive data sets where you don't want full objects associated with every one of the pieces of data coming in. You want as lightweight objects as you can because you've got so much data coming in, and so you tend to separate your code from your data for that reason. Okay, the Singleton pattern. Now this is that we get some really interesting discussion within the coding community on, is the Singleton a good or bad thing? Is it an anti-pattern? Now this concept of anti-pattern is interesting because a pattern, as I was saying, is this idea that you have a good way of solving something that you repeat. An anti-pattern is a bad way of solving something which you repeat. So we had about 25 years ago, 30 years ago now, the discussion about capital punishment in schools, whether it's a good thing to do or a bad thing to do. Now, often people would say, corporal punishment in schools, not capital, that'd be killing people. So corporal punishment in schools. And some people would say, that's an anti-pattern, right? Because, someone does something wrong, you hit them to correct them, and they stop doing it. The problem is that that's not actually really how it works, is you catch them and they get better at not getting caught rather than realize why they shouldn't do something. So, and so that idea of there could be a common behavior that's happening in a society which people think are a good way of solving something, but actually are a bad way of dealing with something. And so just because something's common and something's easy to understand doesn't mean it's the best solution. And the Singleton pattern is one of these ones which keeps going back and forth between people liking it and hating it. So this is a solution to the global variable problem. So how do you access a global variable without having globals? Well, the Singleton pattern is where you create the object on the fly when it's needed. So rather than making it global, you have to find a way of giving a pointer to an object that you'll create when it's first needed, and then that object will stay around in memory and you'll keep a pointer to it. One of the things they talk about this is, the keyboard. Everybody needs it. Like all parts of the program might need access to the keyboard. And so what you do is you say, right, that's going to be a single object, which is the keyboard handler. And with the keyboard handler, when the program starts up, it'll create the keyboard handler and then give me a pointer to the keyboard handler. And then from then on, I'll call that static pointer to the keyboard handler, and I'll just get the keyboard handler from wherever I am. It means that if I wanted to check who's accessing the keyboard, I can put in a wee check to say anytime someone calls this, throw out a message, right? And that's why it's like something better than using a global, for instance, because if you use a global, you have no way of knowing where it's being used in your code. Whereas if you use a singleton, you can put in an additional, basically, logging feature into your use of singletons, and then go, aha, that's using the singleton. Right? So you can kind of manually check where things are accessing. So here, imagine you've got either the keyboard or the screen. They're a single object, and so I might create a single screen handler, rather than creating a global screen object or a global keyboard. Now, how this works is that in OO languages, hopefully you remember you've got a constructor. Well, what you can do is something weird where you make the constructor private. If you make your constructor private, you can then no longer call new on your object, which means you can't create a new version of something, which means that there are no new ones. So what we do is we actually have another static, which is a get instance, which is saying, hey, get me the instance. And internally within the object, it checks, have I already created one of these? If I have, I'll give you the pointer to it. If I haven't, I will privately call my constructor, create a new one, and hand you a pointer to the one that I now have as my singleton. Okay, so what that looks like in code, because often code is better to understand this stuff than my words. So here is, I've actually put it protected so that it can be used by children, but I have a class singleton, public, which is instance or get instance. I have a protected singleton, so I can't get to it from outside, and I have a private static pointer to the instance, right, to the actual instance. And then the key thing is right down the bottom here, where we go that the singleton, when I call that static function, it checks, is the instance nil? If the instance is not null, as in I don't have one yet, then create an instance of it and return that, right? So that's not got the return. It should have it's a return on the line below. So this is the idea, is that you are creating a protected, a private constructor, and so that you you protect, in this case protected private, that construction. So this is that's the standard singleton pattern. It takes a little bit to get used to the idea. Part of the reason people dislike it is because it allows you to do lazy instantiation of things. So rather than being upfront about all the resources I'm going to use, I can wait till later. Now, if those things take time to initialize, and I'm in the middle of something, and they say, oh, right, you want the printer. Oh, well, I'm going to have to take time to initialize that. Then whatever you're doing is going to slow down because it didn't expect you to use it. Now, if I know what my program does and I know that I'm going to use that, I could just do it during startup. So there is a discussion on why wouldn't you do it at startup rather than allow it to happen at any time during the program. Okay, so the wee checklist for your private singleton function. And if you look at design patterns, they'll often give you this kind of checklist of these are the things to remember to do to make sure you're following the pattern. So you define a private static instance, you define a public accessor for the class, you do lazy instantiation, create a first time when it's used rather than upfront. You define all the constructors to be private or protected, and clients can only use the accessor to manipulate the singleton, they can't directly manipulate the object, right? So they have to call the accessors. That's the core of Singleton. Jaws Making Up Time has kind of you can find more there if you want to go and have a look. Okay, so strategy is a bit like the command pattern. It's for updating behaviors in objects rather than kind of configuring keys. It's usually a behavioral system. Again, it's replacing a switch statement, and it creates the virtual class with known methods. So rather than having an execute on a method and just having the execute function, it replaces those with a strategy pattern where the strategy knows that they're always going to have particular behaviors, and you can swap out those behaviors. Now, so here we have this recalculate strategy, and this looks slightly different to the command pattern when you implement them. Again, this is a pattern around changing basically out a switch statement, because no one really likes switch statements. When you're coding them, they feel a bit ugly, particularly the way that they do fall through. It's a terrible coding style. So you often have a strategy where you can have an abstract strategy and a concrete strategy. So the idea is that if we do UML diagrams, an abstract strategy, the user says, oh, this is an abstract strategy, and I will make versions of it, and then when I need to know what strategy I'm in, I will replace those, because it's polymorphic, into the abstract pattern strategy, because they are able to be changed into that strategy. Okay, the last couple I'll talk to are the factory pattern. So the factory pattern is quite interesting, because what the factory pattern is it's about managing memory. Now, most of you probably don't worry about memory for your code. I'm assuming most of you are not writing memory critical code. So the thing with memory is that once you're doing large projects, you start to worry about memory. The naive solution here is you use new and delete. If you use new and delete, you'll get you'll create new memory, and you'll remove memory when you're done with it. So long as you've not got some inner loop happening, that's fine. Problem comes when you are creating and deleting and creating and deleting and creating and deleting constantly. So what a factory pattern does is it says, okay, nowhere, like, we're going to remove new and delete from our program. We're going to put all our memory management and handling into one class. It's going to be the factory. Anytime we want data, we'll ask the factory to produce it for us. And when we're finished it, we'll recycle it to the factory. Okay, so instead of having news and deletes sprinkled all over your code, you now use a request from the factory, right? So you might have do I have some code? Yeah. So you have here some product code. Now it does use a switch statement. It's one of the easier ways of doing this. Just to show you the simple idea. But the idea here is that you've got this AF create, right? The abstract factory has a create, and there are different factories for creating textures, meshes, and items. And the idea here is that when I create these things, rather than the factory, rather than me creating those somewhere else in the code, I'll create them in the factory. Part of the reason to this is that although it just looks like here, hey, when you get it, just return a new texture, return a new mesh, return a new item. That is the simplest way of implementing this. What you do is you actually say to the factory, it will have a pool of available items. So we do this when we look at enemies in games. If you've got a top-down scroller and you've got a maximum of 20 enemies on screen, right? What you do is you have all of those, you initialize those enemies immediately, all 20 of them, and they sit just off screen. You have them all piled up there just off screen, and then what you do is as you call those, and as the enemies come on to the screen, you initialize them with their new position, and you let them fly around. And when they get shot, they don't get deleted, because that would be a delete in the middle of your code. All they do is they get recycled into the factory, and what that does is it resets their position above the top of the screen. So all of these enemies are flying around, and every time you shoot them, they actually just disappear off to the top of the screen and instantly flick there. And so you don't have to new and delete, because you created them when you started, and you just hide them when they're not needed. Now, from a programmer's point of view, it just means that instead of using delete, I use enemy.create, and I ask for it. And what that actually does is the factory goes, oh, you wanted a new enemy? I've got one of those I made earlier for you. And it gives you one of the ones it's got in the pool. And then when you release, right, so you create and release, and you call, factory release this one, the one that you'd got the handle for, and it goes, okay, I'll set that back to off screen and make it invisible, and everything will be fine, right? So it's this idea that you don't create and destroy memory, your program manages that memory itself, right? And you can do either concrete or abstract classes. With abstract classes, you can actually do just you can kind of do type defing and stuff. If you want to use generics, you can create really nice, kind of clearly defined abstract factories. If you want to use static factories, you kind of have to know what kind of thing you're creating, and you explicitly, as you see at the example, with the factory, you call it to create a texture. Okay, so you guys all understanding this? You're still there? Some of you are still there. I think you're still there on the YouTube channel as well. I'll just check just to see. Yep, no, there are still people there. 18 concurrent. Wow, okay, so there is actually people viewing. Great. Okay, so the last one I'll talk about, before I talk about a break and then we can talk about some interesting stuff in memory, is the composite pattern. The composite pattern, well, actually there's another couple composite in spatial index. The composite pattern is the idea that you can define an object as being a child of itself, and it is built of leaf nodes which are composed together. One of the ways of dealing with this is you say, okay, if I'm going to have an array of things, I'm going to have a separate array for every different type of thing. With a composite, you can actually say, okay, now I'm going to have groups. Those groups are going to be composed of different members, and I can build up those groups, and then I can have a single array of all of my composed objects. So this is basically the idea of arranging things into some sort of tree structure that has whole and part relationships, the hierarchy. So I always treat individual objects as composites of objects. So you can try and treat them in the way that you do recursion. You say, right, I've got you, I will look at all your children. If any one of your children has children, I'll look at all of those children. If any of those have children, I'll look at those children. So you can build these trees where I treat any node as potentially having its own children, right, rather than its own leaf nodes. So and you can provide identical functions. So for example, the graphics is the standard place we see this, is you have, in graphics code, you can have a drawer, a drawer for a piece of graphics, and add or remove an item from the graphics, or getting one of the children, right? So you can imagine that you have those in a composite thing called a graphic. There are some primitives. Line doesn't have an add graphic or remove graphic or a get child. It's a primitive. So a line just has the draw function. Rectangle just has the draw function. Text just has a draw function. But then you might have a picture which is a subtype, which is a full graphic. And so here you can basically embed in a graphic other graphics. This is the idea that you are composing objects, and then within those, when you call draw, you can call draw on all of the children, right? So if I call draw on graphics, it will draw all of the primitives that are its children and go through all of its own children to draw all of those children. And so you can get this recursive nature from the data structure of how you've composed the information, rather than having to have something that tries to go through and manually find all the primitives and then call draw on each one of those primitives. Here the function just goes through and calls draw, and the draw function in each of those objects deals with finding all of its children and drawing and calling that draw function. So you can have recursive here where you have a picture with lines and rectangles, and it has a picture with lines and rectangles underneath it. Okay. Did I? Oh, I removed spatial index. Oh, I can tell you about spatial index if you're interested. But following a pattern is good. Helps other people understand your code. Helps spot errors, usually code errors, and leaves you thinking. Leaves thinking to the unique problems, rather than creating boilerplate code which everyone else has done before. Everybody knows how to deal with keyboard mapping, right? You don't need to do something clever. We know how that works. So use the pattern and think about your most challenging problem, and that's where all of your clever brain power should go, not into just standard solutions. The bad is if you pick the wrong pattern, or you have too much faith in a broken or outdated pattern. And some of the OO patterns that we say are, you should use a linked list instead of a for loop, because a linked list has an order one insert and delete. That's actually often not the best idea because of the way the language is implemented. And so it's a good pattern if languages were implemented on the machines the way they used to be. It's no longer a good pattern. So you have to be careful that you're not just falling into the trap of, oh, I'm just doing it the way everyone else does it. It doesn't matter if that's the wrong way of doing it. At least I'm consistent. The area that I find that most annoying, and honestly, and if any of you are doing user studies, and are doing analysis on Likert scales where you get people to make a choice, what they found is that about 70 to 80% of design papers do the math wrong when it comes to presenting their data from Likert scales. So the question to the student is, do I follow convention and do it wrong so you can compare my results with other published work? Or do I do it right and then you can't compare because I have to do it differently to the way that it's done standard? And this becomes part of that challenge of, do I follow a pattern even when that pattern is not the best way of doing things? Now, pretty much every single one of you has in front of you, I would suggest, an example of following a bad pattern because it's common. The one you have is your QWERTY keyboard. That was a good pattern for what it needed to do. It's now a bad pattern for what we need it to do, but because it's common, everyone knows how to use it, we keep using the bad pattern because people are more familiar with it. So whenever you choose these patterns, and if you're going to think of have other people solve this problem, simply cutting and pasting their code might not work. Try and think, is this a good pattern? Is this really solving the problem that my code actually has? So I did have a slot for questions because it's 54. Sondra's still there. Yay, Sondra. And it does appear that other people are listening too, so that's all good. So one of the things I had was do you have any questions about those patterns? Can you see that you've used some of those patterns? There are also a large number of patterns you can look up. If you look up coding design patterns, you will find large numbers of discussions around patterns. You've got to remember that they are definitely restricted to their language paradigm. So if you have an OO language, so you're doing C++ or one of the OO languages, design patterns in OO language will be useful. But for functional programming, the design patterns for OO programming are just not any. They're not good, right? They don't work. So you have to understand the context you're in, and then what is a standard way of solving a problem. Now, part of the reason why I'm telling you to look for these standard ways of doing things is because there's a certain phase of learning when people will tell you to not use the internet and try and solve the problem. That's not how professionals do this. We'll often go and look for the solutions to things, and when you find them, you kind of go, oh, okay, so that's the standard way of doing something. So usually you follow the standard way of doing something. The challenge comes when you try and get many different standard ways of doing things and smash them together. I saw the analysis of the app that the Democratic Party used for the Iowa caucus, and apparently, according to Verge, when they looked at the code, it looked like someone had Googled how do I add authentication to a net service, because it was the code from the first tutorial that you get when you do that search. And it seemed that all of the functions were just the whack together from the first tutorial you found with the name of what you were trying to achieve. Which is also why it fell over, that it was running in test flight. And so they didn't actually roll it out to the App Store. All they did was put it in the internal testing platform, and having 1,600 people all doing the test flight thing, it was always going to technically fail. So that was very poor professionalism. And you can see now that that company probably will have to fold now and may never work again. And they'll have to find other jobs, because when you make a big mistake like that, and it's a simple mistake that you should have known wouldn't work, then people no longer respect you, and your name is not associated with good programming. So you don't want to make those mistakes, but you also don't want to have to do everything from scratch. So you've got to find that balance between coding the solution yourself, because hey, you're clever coders and you can, and saying, no, I'm just going to do this in the standard way. I will look up what the standard way of doing this solution is, check a couple of sources to see that it's standard, and they go, oh yeah, that appears to be standard, I'll just implement that because that's a good idea. So that's where this design pattern thinking comes in, and it's encouraging you to use the internet, and encouraging you to search for things and say, well, actually, the internet is a wonderful place to find good examples of code. The challenge is that you don't want to just cut and paste, because you'll also find some terrible code on the internet as well. I've often got angry at tutorials and particularly Unity has large numbers of very novice programmers who create Unity tutorials because they're very easy to create, and then they say, hey, I got it working by doing this, and they make their little YouTube tutorial, and lots of people think it's fun, and it works for that. And so it gets lots of hits, not because it's the right solution, just because the kid presenting it is interesting, or kind of it's the first one that pops up when you search the term. And so you get this proliferation of very, very bad coding behaviors, because people are using the internet without trying to say, is this actually the standard way of doing it? Should I follow the standard, or is there a better way, given that the standard may break? Okay, so it's now 11 o'clock here, and 11 o'clock still there. I believe that we're still at the 11 o'clock, 12 hours out. So what I'll do is we'll have a wee break, and I'll grab myself a drink, and then we'll come back, and if any of you have some code to review, I'm happy to do a code review. If any of you want to share your GitLab link with me and get me to review your code, I'm happy to do that now, or I can talk to you about memory and pointers and some clever stuff that people used to do with analyzing and understanding how pointers work. So if any of you have code for me to review, send me a message now, and we'll set that up for 10 past. Otherwise, go grab yourself a coffee, stretch, have a wee walk around, and we'll see you back here in 10 minutes. That. Yep, that looks good. people are still here. Yay! Okay. So we've had our 10-minute break just to give you guys a chance to go away and do stuff, and if you're sitting there to have a break and chat to other people and those sort of things. So my video seems to have frozen. I will see if I can get it to unfreeze. Okay, now I'm back. That's right. Okay, so what I thought I might do, if it was interesting to some of you, was to have a look at some unusual bits of the way that you can interact with code. And this actually comes from a technique that was used by what's his name? John Carmack. So one of the challenge that he had was to do with people decompiling code, right? So the idea is that you've got a game. What people would do is they would decompile the code, and they'd be able to trace what the code was doing, and then try and do things like change the score, or if you had some licensing server. So there'd be an if statement, we say if licensed, then continue playing. And the problem was that when you do that, what people were able to do is they were able to hack programs by dipping into the hex code for the program, finding where that if statement returns its value, and then in the return value insert a true instead of a false. And so if you can find where that true false value for the validity test on the code is, you can then patch every single downloaded or every single version of the program, because the executable has the same if statement in the same place. Right? So you actually open up a hex editor, you step through the program until you find the piece of memory, and then you change it. And now, so what he was looking for, and people can do the same for scores and things. So what he was looking for is how can I change a value without someone being able to execute my or decompile my program. So look for where the variables are being assigned and go, oh, that variable is assigned here, so I'll go, and I know that variable is the one that's passed out, so that's where it must be being set to true or false. Okay, that's the one I'll use, right? So it can trace the use of a variable. So what he did is he actually did the whole, when you've got stuff stored in memory, let's say we store a value, the score, in memory somewhere, right? So we have a score, and we have some other piece of information. We'll call it an integer for the player number. So and I'll create this random pointer to an integer called r, and I can set the player number to being number 1, and then I can set the score to being number 50. Okay, that makes perfect sense. And here, if I print out the score, it will be 50, right? So I've got score and I've got player, and I'm interested in playing the score, changing the score. So here, what I do is I set an offset, which is the pointer to score minus the pointer to player. That seems odd. What I'm doing here is I'm saying, okay, in memory, because you created this memory here in this function, this is on the stack, right? So you created the stack memory. This stack memory must be sitting somewhere, and this stack memory must be sitting somewhere. I can work out the distance between one of those pieces of stack memory and the other piece of that stack memory, and I can call that the offset. So what that does is I can actually export. I can print out using the X for the hexadecimal code. I can print out that actual piece of memory where the player integer is stored, and the piece of memory the score integers is stored, and I can output the offset. I then, so I've set score here. Here, I don't pass in score. I do nothing with score. I'm not touching score at all. I am passing in a pointer to the player and the offset I calculated from up here. Now what that allows me to do is say, well, actually, although I'm passing this pointer in, I'm actually going to step along to where the score is. And so in my evil function, what I'd have up here now is that, and we go up to the evil function. In the evil function, again, terrible just short letter names, but there's more that I can do this printing out down here. But this is the key line. I take in the pointer to integer, and what I do is I take that pointer, I add the offset that I remember I calculated for the difference between score and the player position. I move it from where the player position was to where the score is, and then I set that piece of memory to being 10. Okay, so when you now decompile this code, you will not see score having its value changed, because what's happening is that I'm going into memory, I'm wandering down memory, and then I'm changing the piece of memory. So and then after I do player and offset and call that evil function that walks around memory, I'll then print out the score again. Right, so in this code, score was set here. Score is never assigned anywhere else in this code. Right, nowhere else is score passed. It's passed and printed out here, but it's not actually passed. These are just print functions. It's not explicitly changed anywhere. It is now just purely changed in memory. And this was just to talk about multi-threading. So, but if we run this, right, and although I could run this, I do actually have one I prepared earlier. So if I do that one, so this is the output of that, and what you'll see is that this output has, and if I make that slightly larger, I thought it would make, I need to do that one and make that slightly larger. So here you can see it's already printed out the score, and then you've got this integer, my init, and that's the actual piece of memory which that pointer is generating, and this is for the player, and this is for the score, and you can see that it's 3, right? So it's 3 bytes further along. All good. When I do a for loop, printing out the initial piece of memory, starting with the player number that prints out 1, I then step 1 byte, further along. Actually, no, it's an int, so it's actually 4 bytes further along, which is why it goes from 9.8 to 9C. So we go to 9C, and that gives us that, and then we go to AO, and it's just got a random piece of memory, and then we hit A4, and it's got the number 50 in it. It's kind of, that's where it's put 50 as code. And these are just other things, just seeing what other ones. So here is where it says score is 10. That happened after we did that evil stepping through memory, knowing the offset distance, and then changing the value. Now, this is particularly ugly code. It is the worst way of doing this, but it's being done this way specifically to stop people hacking into your code. Now, in the more naive time of the internet, we felt that it wasn't that big a deal that people would would hack into code, so you didn't have to do this much. The reason the game developers were doing this is, and you'd see people doing this with some of the Adobe products, for example, to try and get their licensing servers to work properly because you'd be downloading them. Now what they do is, instead of having those messages kind of tied into the program themselves, they have more complex licensing server which is issuing you codes and updates all the time, and so all you've ever done is bought a license for your product rather than actually bought the product and had the download of that product. But if you look at this code, this is a way of achieving some of that complexity, and doing kind of really weird ass things. Now this for loop I'd put in here for optimization reasons to say this is how you count down from 10 down to 0. It used to be that this was a faster way of doing things. No longer is, because the compilers make the speed faster for a normal counting up loop. These two A and Bs I was actually using when I was doing multi-threading. So this was just a simple example of playing around with memory. Now, there are some even worse things you can do, which is what actually Carmack did, is that because you know that the memory on the stack still exists after you come back from a function, you can go hunting in the functions in the previous memory that's been released, right? So you see this return P here, that is actually this R is pointing to the P that was returned. The P is from this value that was on the internal stack of that function. So the idea is that you can actually, that P is set to Q, and Q is pointed to an integer. So Q is set to where that P is. Can't remember why I set S to 27, just as an interesting experiment, because I was going to do it down here. You can see I've got various things. And here I'm going through and doing print and print off, and then I return this Q. And the idea is that you can actually step through and change those values after the function's exited, right? And you can read those values after the function is exited. So if I set S to being 27, the idea is that sometime after I get it back, I could step through and find that number 27 and do something about it, right? That is a absolutely crazy, evil way of doing things. But these are those techniques that you might find out there where you're trying to do something explicitly to break people hacking your code. Now, as cybersecurity people, you do have to, well, some of you might be interested in cybersecurity, there is a requirement and an ethical requirement to try and do a reasonable job of making your code secure. And certainly with GDPR, you have to do a reasonable job of keeping data secure. So some of this oddness that you might want to do is ways of trying to meet those minimum standards. Now, the other, so I'll just see if there's anybody with any other, no one else has come up with any other code that you want me to have a look at. I was thinking that I could also do a little bit of the file open new solution. So I also have a whole bunch of other code in here, and so you've got some code for design patterns, and some code play. But so the idea is that I can actually talk you through some of things like Lua scripting and how some of that multiple languages stuff works. So for example, here is examples of scripting in Lua where we're combining two languages, and that idea of creating a scripting language. You also find this, you will find this in large professional tools, is that rather than just having default options all the time, and I'm sure you having used Unity, you see this, is you created the parameter system, right? So what you're doing is often you'll set a config system for the tool you're using, right? So you'll have a standard configuration file, and in that configuration file it might have number of or maximum number of entries or something, right? And that might be 10,000, say. And then you might have number of columns or number of variables or some other value, right? At some point someone's going to look at it and go, there are 4 times as many of this thing as there are of that thing, right? So when I set the number of pairs, what I want to do is I don't want to just set it to a number. I want to set it to a multiple of something else. The moment someone says, I want to set this parameter to be related to another parameter, you immediately move into the idea of, oh my God, now we've got a scripting language, right? Because what you do is you can have a parser that will go over your config file and will look for things like star as a multiplier. And then you are able to create your own language where it says, if I see a star, take the first side and multiply it by the second side and use that number instead, right? And that means you can set things up as being 8 times 5. However, if you've already parsed all of the ones that don't have any multiplier in them, and you treat those as your statics, right? You can then go, oh, this is a variable times a value. If it's a variable, I'll go find the variable and use that in my multiplication. And that basically is creating a scripting language. And so Lua is gone the whole hog and said, well, actually, let's just create a whole language which interfaces with C++ or almost any other language. And people can learn to write in Lua, which is a simplified scripting language, and all the code will be implemented in a fast language like C++. I don't know if any of you have started writing config files, but if you do write config files, it is very tempting to start thinking, I could just add a little plus, or I could add a check for a multiply, or I could check a semicolon, or I could check a less than symbol, and then I could have my config file do more than just be a raw static number. That's how all of these scripting languages get born. As a professional, it is a very useful thing to offer your users a scripting language so that they can have more control over how your tool works. The moment you give them any control over how the tool works, they will break it, and they will repeatedly break it, even if you give perfectly clear instructions and absolutely perfect examples. Your users will still break your scripting system. They'll put the wrong numbers in, they'll multiply by things that don't exist, they will just generally break the system. So anytime you're weighing up, should we allow our config file to become richer and more complex and eventually become a scripting file, which is just simplified code, you have to be careful of that. Now sometimes what you'll see is people go, right, we'll make our config file JSON because it's extendable, it's XML style, and so if we do want to add stuff to the config file, then we can because it's just in JSON. And JSON allows you certain amounts of configuration, right? Because it's JavaScript, it's a scripting tool. So it allows you to have some evaluations going on there. I would recommend. I wouldn't recommend writing your own scripting language. I would recommend you use existing tools where you can, and potentially use something like JSON object formats so that you can share those with other programs more easily. So the way that Lua does it is actually it has something called a Lua state. So when you communicate between Lua and your C++ program, there's a Lua state. And that's a push-pop medium. So you push things onto it, and then you push some data on, and then you push a function on, and you pass it to the Lua for processing. Lua takes out the name of the function, and goes, oh, it's that function, and then it pulls off the stack the values that it's to put into that function and processes it and puts the result back on the stack, and the stack is what goes back and forth between C++ and Lua. So here this was just a simple SDL system, and with a wall and a Lua state, and the interesting keys. Those are just standard SDL updates. SDL. The key is actually when we go into moving, and we have, where are we? Get down here. There we go, Lua. This was an example of Lua being able to call a function in C++. The function, for a function to be able to be called, it has to be past the Lua state and have a name. And so that's what this is past. It's past the Lua state and has a name, even though it's spelled without the U, and it will print something out. So I can test to see, can I see the word color? Here I've got a more complex function called closest enemy. Now you should be able to think closest enemy. You probably know what that means. You give it a Lua state and it gives you the index number of the closest enemy. It doesn't actually return an object which is the closest enemy, just the lookup, the ID of the object. And here you've got argcs, which are just like you're starting up for the program. You have an argc and an argv. And here I was doing some checking of distances, and I pop off into L the Lua state. So this Lua pop takes the Lua state and pops off the first thing, which happens to be the name closest enemy. It then goes through all of the argcs, right, which is get the Lua top of the stack. It goes through and says, right, I'm going to put to standard error all the things I got so I know what's been passed. It then does the distance x and distance y for the enemy. This is just the only enemy rather than the closest enemy. And then it pushes those onto the stack and returns the number 2, saying that there are 2 things that have been pushed on the stack. They are the x and then the y. Now they have to be pulled off the stack as a y and then an x because it's a stack. But that's that push and return. That is how you communicate from Lua asking C++ something, C++ working it out and returning that value. Now within this program, we can also grab the Lua file, but here there are various error states, and you can have an AI update, which is what it was doing, and then the main start of the program, where this is the interesting Lua stuff, where you're actually registering the. Remember, I said there's a function called color, and it would say hello. Well, this is where you register with Lua the name of the function within C++, which is on here, and you see closest enemy and closest player there. And this is the Lua name that it will have. Right, so closest enemy is in Lua becomes find bad guy. And so if I open file, actually I've got the Lua script. Do I have the Lua script in here? Thought I had the Lua in the source files. So if I just go file, open file, and I am here, and there, test. Okay. Okay, so here this would be with the Lua script, and so it's got some interesting things like find nearest bad guy. I give it 1 and 2, and it returns an A and a B because Lua returns multiple values from a function. because remember I said in my stack I pushed X, I pushed Y, and so here I've got nearest bad guy is at A and B, and I can just return that. I set the enemies, I can update enemy, and I can say hello, and here you can see I'm calling the function hello, right? Now Lua also has its own IO, right? But I was using the C++ within this function. Now, it knows what the function hello does, partly because, well, actually entirely, because in here I've registered a function called hello that will actually call this color function. Did I put it at the bottom or did I put it at the top? I put it at the top. So this, where is it? There it is. This function gets called when Lua uses the function called hello. Normally, best practice is always name your functions the same so that it's you're not having to kind of remap and re-understand what's going on. But that's this idea of having a scripting language where you've got a tool like this where you can write relatively simple things and a limited number of them, compared to a full programming language where you can write anything you like. Okay, well I'm going to stop at 11:35 because nice, well done, Carl. You guys are using Lua config files. Lua config files, perfectly reasonable way of writing config files. They do allow the user to do some things which are quite nice, and they give you that power. And hopefully you found that it wasn't too hard to add Lua config files. There, like with the latest Lua, it's actually really easy to do things like a simple config file, and it means you don't have to do as much integration of those functions, but it's a good standard way of doing a configuration. So the last thing I was going to talk about, and I've still got you guys here, and still a bunch of you online, is to actually talk about the course, because we have to get a class rep. So I need one of you guys to volunteer as a potential class rep, and I'm supposed to lean on you until I get somebody, and then I'm supposed to lean on that person to have some form of meeting with me to actually give me feedback about, is this okay? Distance teaching is always difficult. I'm sorry that I can't fly over to Norway every week to see you guys. I very much enjoy being in Norway, but traveling for 36 hours and then spending an hour with you and then traveling back, or 2 hours, and then traveling back 36 hours tends to knock out my week. And so I'm not going to do that to the planet either. But what we need to do is we need to work out if there's any feedback, what are you finding difficult, what can I help you with, and where are we going in terms of what you want to learn. So rather than us trying to do that all in a single session like this, I'll need somebody to volunteer to be that class rep. So now if you are keen, then we can organise that meeting. The other thing is we need you all need to think about distance teaching. Is this a viable way of being taught this particular content? I hadn't taught this content before, so I'm still trying to work out what's the best way of teaching this stuff, because normally I've done it very much in the room with people. Also, given that with viruses, potential pandemics, there may be a lot more of this distance teaching. So things that I'm doing well, you should think about and give us feedback on, so that I can hand those over to other people who need to do distance teaching. The other thing that I think is important to do is also to work out what else you need. Now, I've had a couple of people ask me on Discord. One of them was wondering about the continuous integration stuff, and how to get that working, and I was able to debug that remotely, so that was okay. If you have coding questions, you need to ask me, right? I am a resource. I've been coding for a long time. I can probably work out what's going on. And I want to see more of that code, and I want to do more code reviews for you so that we can go over how your code works and improve it. So, is that someone saying a teddy bear there, that koala rather? So Carl, are you koalaing willing to be a class rep? Or was just that saying koala, drop bear? I'm not sure how much pressure I'm supposed to put on you. I'm assuming other courses have put pressure on you to be class reps on the general students. Would that be correct? I'm assuming that people have had the heavy hand of you should be a class rep handed onto you. He's qualified. Of course. That's fantastic. Yes, okay, so Carl and Thomas, you are qualified to be a class rep. That's so lovely. So if you guys, I see you're also, Carl, you're also an admin here. No other classes. Okay, nice. So it's a quality pull. Yes. So Carl, if you're willing to be our class rep, what I would suggest to students is, and I can add you as a class rep role maybe, but anyway, I will put you on the website as being the class rep, and then people can send you concerns that they have, right? Because I know that it is difficult to work remotely like this, and I know that that there are potential other challenges you're having. So if you are concerned, or there are things you want to say about the course, you can go to Carl. Carl will also tell Marius, so my boss in Norway, but he can also come and have a meeting with me. Come and have a meeting. We're going to have to do it online. No, class rep does not get a free trip to New Zealand. Otherwise, you'd all volunteer. But Carl and I can have a meeting, and we can give feedback on the course and make sure that I'm still being responsive and able to give you what you need. Hopefully you're all working through your bachelor projects now and are finding useful things to be doing in those bachelor projects. I think either next week we could do the ethics, or we could do comparative languages, and I can talk about functional programming and logic programming and imperative programming and object-oriented programming, and discuss pros and cons of different paradigms of languages, and we can look at a bit of Elm as I find Elm a bit easier to understand than Haskell, but as a sort of web-based functional language, and we can look at some of the simple ways that it does things to try and get you to think differently. That won't help you specifically with your bachelor theses, but the idea that you've looked at a functional language and that you've coded a little bit in a functional language is quite a useful thing to have done as a programmer. So I still would recommend to take some time out of your thesis and do that. Okay, I'm just going to play with a functional language for and a couple of hours just to get a feel for how it does some of those things, right? So we've got a playground example of that for you to do. Okay, does that make sense? You guys happy with that? So we'll look at comparative languages next week. And as an aside, I will find out if I end up being a politician in 10 days time. So in 10 days time, so next week I'll have a standard lecture. The week after that, when I give you your lecture, I will be able to tell you whether this is the end of my stint as an academic and the start of my stint as a politician, or if it's or if I missed out and they picked lawyers to be the politicians rather than computer scientists. So that's now 10 days away. So I know when that is. So I'll keep you guys posted. If there's nothing else, it's 1:45. It's 1:45 on there. So I'll let you go away and have an early lunch, unless there are any other questions that anybody wants to bring up. And I'll check on the YouTube channel just to make sure I get all of the questions, not just the questions here. Nope, no one said anything on the YouTube channel, that's fine. People have been following along. Great. So, great that some of you are using scripting languages, even if it's just for the Lua config. It's a simple way of getting a nice config in there, and it gives you some flexibility in that. Think about how much flexibility it is. Think about, do you need all the flexibility, or do you just need a flat XML file? These are interesting discussions to have. But again, if you over-engineer it, if you give people a full scripting language, sometimes they'll expect your program to be able to respond to all of those, and if it doesn't, they get upset, right? So do think about, when you add that level of technology, is it the right thing to do? Okay, well, if none of you want to ask me any questions, I will upload that lecture to the GitLab site. I will also I will DM Carl to work out a time when I can meet, and I will send a Blackboard email to all of you with Carl's contact. Once I've DM'd him and worked out what he wants the contact to be. And then you can start giving your feedback to Carl, or say to Carl, hey, I wish Simon would get a haircut or something. And then he can pass that feedback on to me, and we can satisfy NTNU that there is actually, some student feedback and some student process. Okay, so have a good night. I will DM Carl, and we'll see you next week. Okay. Night, guys.